In this video, we're going to start with problem number 26 as we look to explain the review solutions for exam 2. Problem 26 says, suppose you roll a single fair die. What's the probability of getting a 4 or a 5? Now, when you roll a single fair die, you can either get a 1, 2, 3, 4, 5, or 6 on it, obviously. Now, what is the probability of getting a 4 or a 5? Those two things do not overlap. You either get a 4 or you get a 5. So you can add those two probabilities together. The probability of getting a 4 is 1/6. The probability of getting a 5 is 1/6 because they're 1 out of 6. So when you add those together, the numerators make 2/6 or 1/3. On problem 27, it says, suppose you draw one card from a standard deck of cards. What is the probability that that card is an ace or a diamond? Well, let's look at the sample space for cards. Let's draw that out. So here we see our sample space for drawing one card. We want the probability that a card is an ace or a diamond. So here are the aces. You have the aces of hearts, spades, diamonds, and clubs. And here are the diamonds in this row. Oopsie, kind of messy. All right, so you have 13 diamonds, and 4 aces. So the probability of drawing an ace is 4 out of 52. The probability of drawing a diamond, there are 13 diamonds when you go from ace to king. So the probability of drawing a diamond is 13 out of 52. But then we subtract out the overlap. Notice we counted this ace twice. Here when we counted 4 and here when we counted 13. So we subtract 1 out of 52 because we counted it twice. This is the way we do OR probabilities if you have an overlap. So if the two events are not mutually exclusive. So we did the probability of an ace plus the probability of a diamond minus the probability of a diamond ace, or the ace of diamonds. So you get 4 plus 13 gives you 17, minus 1 gives you 16 out of 52, which reduces to 4/13. Let's look at problem 28. A teacher asked a class of 40 students about the classes they are taking. 17 say they are taking math, and 31 say they are taking English, and 15 say they're taking both math and English. What is the probability that a randomly selected student is taking either math or English? So if we look at this, we have math here, and we have English. Ooh, I don't like the way those are drawn. Let's try this again. So that left circle is math, and the right circle is English. So much better. And there are 40 students total, so we know our number down here is 40. 17 are math, 31 are English. Notice if we add 17 and 31, we get more than 40 students. So how does that happen? Well, 15 are taking both, so there's 15 in this overlap. So if we look at math with 15 in the overlap, there are only 2 that are taking only math because it said there were a total of 17. So 15 are taking math and English. These other 2 are taking only math to a total of 17. 31 are taking English. Well, 15 of those 31 are also taking math. So if you take 31 and subtract 15, that leaves 16 that are taking only English. But if we use our formula that says the probability of this or that, we add the probability of the math people, which would be the 17 total out of 40, the probability of the English people, that would be the 31 total out of 40, minus the 15 that we counted twice, because we counted this 15 when we added 17 and 31 together. So when you take 31 plus 17, you get 48. If you subtract 15 from that, you get the numerator of 33 over 40, which is the answer to this question. Now, if you would have drawn it out like this, you could see if you just add these 3 numbers together, 15 and 16 is 31, plus 2 is 33 also. So there is a way to do it without the formula. However, the formula is helpful because then you wouldn't have to draw it out. Just add the probability of math plus the probability of English and subtract the overlap, just like we did up here with our card problem. Let's look at problem 29. A student observes 46 vehicles in the CCC parking lot. He noticed that 12 of the vehicles are red and 19 of the vehicles are four-wheel drive. So remember, the total he noticed was 46. 12 red and 19 are four-wheel drive. What is the probability that a randomly chosen vehicle is red or has if the probability that a randomly chosen vehicle is red or has four-wheel drive is 0.609, what is the probability that the car is red and has four-wheel drive? Okay, so this is a tricky problem indeed. Our or formula says the probability of one thing or the other is the probability of the one thing plus the probability of the other thing minus the probability of the overlap. We did that in these two problems above. The probability of one plus the probability over minus the and part. So now we simply fill in what we know. Here they told us that the probability that it is red or has four-wheel drive is 0.609. That goes over here. So we have to solve an equation in this one. The probability that it's red, he noticed that 12 are red. So that's 12 out of 46 because there are 46 total vehicles. He noticed that 19 of the vehicles have four-wheel drive. So the probability of four-wheel drive here is going to be the 19 out of 46. But he wants to know how much is in the overlap. What is the probability that a car is red and has four-wheel drive? So we have to set the problem up this way, where we say the 0.609 equals 12 over 46 plus 19 over 46 minus the probability of red and four-wheel drive. So in this case, we are going to add these two together. 12 plus 19 is what? 31? 31. So what we have here is, I'm going to write this equation. 0.609 is going to equal that 31 over 46 minus the probability of red and four-wheel drive. So now we subtract this from both sides. I didn't show that step, but that's what has been done. And let's see what we get. Oh, whoops. Hold, please. So with the calculator, I took 0.609 and subtracted 31 over 46. And 31 over 46 is about this number here, 0.67313913, excuse me. So when you do that, let's see what you get. You get a negative, actually, 0.0649. All right, and that would equal a negative because back here this was being subtracted, and here this was subtracted. So when we move this over, this part is negative, but this part is still negative too. But the way we get rid of a negative that's being multiplied by something is we divide it out. So if I divide a -1 out of my left side, I'd also divide it out of the right side, meaning that the probability that a car is both red and four-wheel drive is just that 0.05, no, 0.065. Because we round to the third decimal place. That's how we wanted to approach that one. Let's go on to problem 30. 30 says a jar contains 3 red, 4 blue, and 5 white marbles. A marble is drawn and the colors recorded. Recorded, the marble is put back into the jar and the second marble is drawn. Is this drawing of the two marbles in this manner independent or not? Explain. And we'd say, yes, these two events are independent because you replaced the marbles. So the second draws probabilities are the same as the first. It does not change the probability. But in example 31, where it says we have 3 red, 4 blue, and 5 white, and the marble is drawn and the color is recorded, but then the marble is not put back in the jar for the second marble to be drawn, is this independent? And we'd have to say no. Because by not replacing the marble, you have made the probability different on the second draw. So the events are not independent. So these two examples pretty much just explained independence and not independent. Anyway, that should be the rest of it. More videos will come with the rest of the explanations. Thanks for watching.